The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to the 5th webinar on SimSolid. We'll give 1 minute or two for everybody else to join in. If somebody could say you can hear me loud and clear and also see the screen, I'll appreciate that. Thank you. Okay, right, I think we'll start to begin. So again, welcome to the 5th webinar. And this webinar, we're going to talk about bolt connections. So the brief agenda is, after a short introduction, I'm going to use Inventor Nastran as a workflow to show you what is normally required to do the bolts analysis, and then we'll go into SimSolid and show you the alternative workflow so you can appreciate it. The example I have used is not a large example because I don't want to be spending a lot of time creating bolts, but you can appreciate how much time is required to do the bolted connections within Nastran as compared to SimSolid, so you can appreciate it. And then we'll just finish off with some Q&A. Now, first of all, let's have a look. Many of you here are already using the Autodesk solutions, primarily Inventor Nastran and Inventor Stress Analysis. So depending on who I speak to from the customers, Inventor, in my opinion, can't be used to analyze bolted connections, but I have seen customers analyzing Inventor fasteners. But the only difference is that when people want to analyze bolted connections, they want the ability to be able to actually apply preloads. So if you apply, so you can model it in Inventor in brief, but obviously you can't apply preloads on the actual bolts itself. And that is in the same, similar to Nastran, if you want to use the bolted connections. But in Nastran, we can actually create bolted connections without using the Inventor fasteners. And that is primarily using classical method, which is primarily used in many of the FEA softwares, like namely ANSYS and Abacus. One thing to note that is when we are analyzing bolts in Inventor Nastrans, we don't simulate friction between bolts and the geometry. It's basically using a beam elements and truss elements, and I'll go to that and you can see it. So the workflow typically involved in Inventor Nastran is that we have to suppress the bolted connections, and then the most tedious part of it is that we need to go and split faces to represent where the bolt heads or the washers are actually going to be the size of the washers, so that the load can be spread. And that is the most time-consuming process, in my opinion. And then we're going to go and then redefine bolted connection within Nastran. So that is sort of the brief workflow which we'll go through in Inventor. And in SimSolid, unless you've already been having a go on the software, I would suspect, you can reuse the bolted connections. And the part I like most about it is that it creates contacts automatically, and they are the right contacts. For example, it creates bonded and sliding contacts. So that is a big plus within SimSolid. So I'll go through these different workflows. Okay. So we here have a simple assembly with some fasteners, and it is a simple fabrication. And you can see here I have got washers and nuts in here. So we can basically, I've got two types of bolt connections as defined by Nastran. That's a bolt connection, and these are cap screws in the bottom three. So I'm not going to, in the inventor, obviously, you can model it as it is and define the contacts, and basically the only downside is you won't be able to apply a preload, and that is typically what is required when everything is being fastened down with bolts. So I'll use the process in Nastran, which is very similar, but before we go into there, we need to suppress the bolts. So I have already created a level of detail in here. Now, one of the things in here, you can see here, if I show you the views shaded with edges, now you can see here, if I was to create a bolt now within Nastran, I only have this edge, which I can select. Now that's like having a bolt which is hanging off the edge of the hole, which will basically create a very, very high stress. So what I'm going to do here is I'm simply going to activate the part, and this is the process which we have to go through. So if I go into here, okay, and then we can simply project geometry, and then you can define the washer diameter, and this area is where the load will be transferred from the bolt onto the plate. Okay, and then I'm afraid you have to do these for all the bolts, so we just simply okay, and then I think we need to do one on the other side of the other component. Now once you've done this, we then need to basically, if I just bring back my sketch, okay, so now we need to split the faces. So if we simply pick the split tool, and I'm going to do this for all of the sketches. Okay. And just one more at the back end here. Okay, and I think they're almost done. So obviously you can see here already that if you have lots of bolted fasteners, it's probably going to take a little bit of a while to do this. So hopefully, okay. So we're just going to remove the sketch dimensions. Okay, we got the edges here. And now we're ready to go into Nastran. Okay, so the first thing we notice here, I'm gonna use the mild steel. It's gonna be assigned to everything, and let's just simply let's create the fasteners first. So now in the fasteners process, as you can see in Nastran, we have the bolted connections, and we have two types of bolted connections within Nastran. One is a through bolt, and the other one is a cap screw or threaded bolt. So first of all, we'll do the bolted connections, which is the top one here. Now you can see here, I can either pick the edge or I can pick the face. Now, it's not good practice to pick the edge because that will result in high stress singularities as if the bolt is just hanging off the edge of the bolt hole. So we'll pick this one here, and by default, it picks the diameter of the inner hole. And then we're going to go and pick the other side. And this is not a 3D bolt, it's basically a 3D representation of a beam which is going to go through the middle. And typically we need to specify the washer heights on both sides. And then I'm going to use mild steel in this case as an example. And then you have two choices to be able to apply a preload, either an axial preload or a torque. So we're simply going to apply a preload here now, and then we're just going to press OK, and then I'm going to repeat the command for the other bolt connections here. So we'll just go and just pick this one here. Now the slightly difference here now is it's going to go and ask for the threaded area. Now if that threaded region is not going to be fully threaded by the bolt, then I'm afraid you'll have to go and split that threaded region again. So it's more work. So we'll assume the bolt's going to go along the whole thread. And we'll simply go in here, specify 3, oh sorry, it was 4, and 16,000. And this time, one of the things I like about Nastran here, I don't have to go and close the dialog box and redefine all these values again. I can simply go into next here and define the bolt base and the thread, and then go into here. Okay, and then this. So this is the bolted connections within Nastran. So that's the part here. Now, obviously, I forgot to do the pin, bring the pin in intentionally. As you may have, some of you might be aware that we can suppress parts within Nastran. So if I exclude that from analysis, and we're simply going to apply a bearing load on here, and we do the same thing in SimSolid. So if I pick this one here, it's going to be in the minus X direction. We're doing a half a model, so half a load. Okay, and we're just simply going to restrain this box section here. Okay, and the only thing left now is we simply need to go and define the contacts. We'll do the automatic contacts, and we'll have a quick look now. Obviously, it's brought up the contact between the pins, so we can simply suppress that. It's a bonded contact, so we can change that to a surface contact. We can specify friction, but I'll leave it here for a moment. And now we can just, I'm going to keep the default mesh. I do understand the mesh is not fine, but we'll run this. If I just change the color so you can see the mesh. Okay, so we have, so this is an example here, so we can run this. The reason why I've left it as a coarse mesh is hopefully run a little bit quicker. Now what will happen now is that one of the things we can do in here, Nastran, is we can look at the stresses in the bolts. And also I just want to, we have some new audiences here, so I just want to show you the differences and the speed of the analysis as well. Okay, so let's have a quick look here. So we have a stress. So the stress we see on the model here, okay, we have high stresses here because you can see it's a coarse mesh. We have a stress. So the way Nastran works is that the first stress you look at is in the geometry itself. And what we can do here is we can then change the results types to beam von Mises. And this then basically gives you stresses in the beams, as you can see here. And we have different colors, and we high stress in the beam. So we just got to basically make sure that the stress does not exceed the yield limit of the bolt materials. You can also look at shear force and axial forces also within the beams within Nastran, but just wanted to give you a feel for what is involved inside Nastran. So now what we'll do here is have a quick look at SimSolid. So what I've got here is I've brought the SimSolid part, the same materials. Now the only thing I didn't do is switch on the automatic contact, so I'll switch that on now. and this will create, and you can see all the bolts and fasteners have come through, and we're basically going to see all the connections and all in here. And if I simply, first of all, let's just apply a structural linear analysis, and also we'll apply the same material to everything. Okay, so we have the same materials. Now what I can do here is we can have a look at what is happening. If I pick this bolted connection here, we can review the part of the connections. And the one thing I like about SimSolid here is you can see here it has automatically configured the contacts on the fastener. So we have the bonded contact between the washer and the bolt head. Then we have a sliding contact between the bolt and the washer, and also with the washer and the plate. You can see this one, sorry, the bolt and this plate here. So it saves us going and modifying all these contacts within the analysis software. So this has been done automatically. You can modify these to whatever contacts you want. So if I just cancel that, let's just show it once more. So if you want to change any of these contacts, you can see here, you can pick and choose whatever contact you prefer. So you can modify these to your liking. So that's one of the things I like about in SimSolid. All the contacts have been predefined and pre-selected. So what we'll do here now is we'll simply go and do the same thing we did inside in Nastran. So the first thing I'm going to do here is to suppress the pin. Now we can go and define the constraint. So I'm going to pick this side here. Okay, and the next thing we're going to do here is apply the preload or the bearing load first of all, and 15,000. And this, I think, is the cool part. Now if we have a bolt through, then we can have nut tightening and bolt tightening. So I'll pick the nut tightening first to show you different examples. So the software is clever to distinguish between a nut and a bolt. So if I pick this nut here, we have a thread pitch of 2.5, and we can apply a force of 16,000. And same, and then we can do the nut tightening, which is the bolt tightening, sorry. And we can pick these all, that one, and same pitch. And you have different types of turns. You can do it. You can have number of turns. You can specify torque, similar to Nastran, and we're going to specify 16,000 newtons. Okay, so now we have defined all the conditions, and obviously SimSolid doesn't require a mesh. Now one thing I had forgot in Nastran was I didn't define symmetry, so we'll define symmetry in this case here. So we can specify symmetry using a slider. So now we have a fully defined boundary condition. So now we can check. So we're okay, that was a simple check to make sure that everything is working. And now we can run the analysis. So this is going to the three different iterations based on the, if I just click on that for an example, is on the stiffness. And if you want more accurate results, we can do this adapt for stress like we did in the early webinar. So if I cancel that to show you the results. So let's look at the stress results. Now you can see here, unlike Nastran, we're looking at the stresses in the bolts and the whole body here. So I want to look at the maximum stresses in here. So what we'll do here is zoom into that area there. And this is one thing I like. You can see here the highest stress is actually in the bolt itself here. So this is one thing I like about SimSolid. You can actually zoom in and it sort of makes everything else transparent. And then if I want to look at this plate here, and it goes everything else out again. Okay, and the other cool thing about SimSolid is what you can do down here is it gives you a list of all the axial forces, shear forces, bending moment diagrams in all the bolts in the assembly, which I think is pretty cool, and it's not so straightforward in Nastran to be able to capture all this information. So I hope it's given you a sort of a brief overview of what is possible and how easy it is to analyze both the connections within SimSolid. Obviously, it was a simple example with 4 bolts. Now you can think of that if we had an assembly with over 100 bolts, for example, which is feasible and possible. I have seen some examples, then it's almost a tedious process in the current Autodesk solutions. Within SimSolid, it's just pretty straightforward. Okay, so let's go back to so if you're all new, so I have some new audiences here, so just would like to briefly mention that the SimSolid trial is still active through this uncertain times. The link to download the trial is from our website. You can click on this link here. You'll get the video afterwards, and you have all the full support from Altair and SimSolid. And one of the things I think is nice, if you have the time, you can sit on one of the Altair one-day SimSolid training courses if the place is available. Now, don't forget to attend our last session, and in this session I have a very large example of a welder fabrication and over several hundred bolted connections. One of our customers, courtesy of Pilkingtons, and it'd be nice to see how long a typical example like this would take within Nastran, and I will be doing it live within SimSolid, and you can then compare and get a feel for how long it's going to take. And now I'm ready for any questions anybody may have. I know it's been a while since we had our earlier sessions, so I'll hang around for a couple of minutes, and I do hope you can join me for our final session next week. Okay. Well, okay, guys, thank you very much, and I hope I can see you guys next week. Thank you very much for your time, and bye for now.